So my presentation, I'm going to cover just a little bit about the wastewater part of East Bay Municipal Utility District, and then focus on our what we refer to as our green factory, and then the connection of this green factory and how that led to expansion of renewable energy production, and finally just the water nexus connection from the wastewater perspective. So just a little bit about our service area. You may have already seen it here this morning, but the green is the entire East Bay MUD service area, and that's 1.3 million customers. A subset of that is this cross-section here, and that's the wastewater service area, serving these 7 communities, and up here in the north, the Stige Sanitary District. So this is our energy use right now. We use about, on average, 5 megawatts at our treatment plant, to run our treatment plant. We're fortunate that we don't have a lot of pumping in our system, so we have a small percentage that is pumping in our collection system. We have some unique facilities that are remote to the main wastewater treatment plant, which is situated at the base of the Bay Bridge. These are up north at Point Isabel and down south at Oakport, and we also have an intermediate one near Full Start Island. And these are wet weather treatment facilities that only operate when we get large peak flows during heavy rainstorms. So our peak during these wet weather flows, so when the large flows come in and we do a lot of pumping and treatment, our peak can get up to 10 to 11 megawatts. And what we're using here is about 44,000 megawatt hours per year, which is about equivalent to 6,000 California households. So this is our treatment plant. So there's the Bay Bridge, and here we're located right here. It's a typical wastewater treatment plant. It achieves secondary. It does do it through using pure oxygen, which is a bit unique. So we have 650,000 customers, 88 square mile service area. And here about a little over 10 years ago, we started what we refer to as our resource recovery program. And in the 10 years, it has matured quite a bit. And I'm going to tell you a little bit about that program. Our average annual flow, daily flow at the plant is 80 million gallons per day, and we have a secondary capacity of 168 and a primary 320. So this concept that we kind of invented was this green factory model. And that is that a wastewater treatment plant, you go way back when it was just primary treatment, it was really just kind of a discharger. And it then went into the 70s, and all the treatment plants in the country converted to secondary treatment, and we were looked at as a protector of public health and the environment. But now we see ourselves in a new role, and this is catching on across the nation, as a provider. So a provider of resource recovery, taking materials in and recovering those resources, and even in the process, producing renewable energy. So what's driving this? Obviously, there's a huge focus on sustainability in the country. The need for utilities to be environmental stewards. There's some economic benefits, some real economic benefit to taking in waste and producing renewable energy. And then, of course, climate change impacts. So that if you can take in waste and produce renewable energy instead of taking oil out of the ground and producing energy that way, you can actually have some positive greenhouse gas impacts. So this basically is the model. So here you have the wastewater treatment plant, represented as a green factory. You have high-strength organic waste. These could be from like food processing, cheese manufacturing. You actually have food scraps, of which there are a lot of food scraps in the Bay Area. Just from the commercial source-separated type of food scraps, that's grocery stores and restaurants, there's over 2,000 tons per day that are generated. You also have things like fats, oil, and greases. So restaurants have grease traps, and the intent is to get the grease out of the wastewater flow before it gets into the pipes and plates out like cholesterol on your arteries, and those have to be pumped out. When they're pumped out, you want a place to take those fats, oil, and greases. You certainly don't want them dumped in a manhole at the end of the cul-de-sac at midnight. So a wastewater treatment plant is a good place to take these. And then, of course, you have the typical flows that come in via the pipes that come into our treatment plant. And what you can do with these things, or you can produce renewable energy. You can actually produce biodiesel, which we've done. You produce a byproduct of the treatment plant called biosolids, which is a stabilized solid material that has some fertilizer value and certainly soil amendment value. And you can recycle the water, treat it to even a higher level than what is typically required before you discharge, and use it for irrigation and industrial reuse. So here, a little over 10 years ago, we were looking at our treatment plant. We used to have a lot of food processors in our service area, and these moved out and went to the Central Valley. So we were sitting here, we had some excess capacity, and we were trying to figure out how can we use this to the benefit of our ratepayers. One idea was, well, if we brought in some trucks and actually had them dump waste here, we could charge them a tip fee, and we do have a lot of excess capacity, so why not do that? So we started doing that. We looked back. In the past 10 years, our record showed we had brought in 1 septage truck in a 10-year period. We streamlined our processing, our permitting for this, and lo and behold, we were bringing in no time at all, 10 or 20 trucks a day. We then progressed to the idea of fats, oil, and greases. As I mentioned, fats, oil, and greases are collected in a service area. What do you do with them? You can bring them into a treatment plant, and they are high energy. You can actually anaerobically digest these and produce energy. So we did that, and the trucks started increasing, 20, 30, 40, 50 per day. We expanded it to food waste processing. So cheese manufacturing produces a waste material. That waste material is very high in energy, and you can put that in a solids processing unit at our treatment plant called anaerobic digesters that use natural microbes that, without oxygen, that break down that material and in the process produce methane gas, which is natural gas, and a stabilized byproduct, which also goes to biosolids. So we brought in food processing waste, the winery waste up in the Napa Valley, also industrial and commercial process water, such as water, well water, well purged water, and tank rinsing, animal processing. So Foster Farms has a big animal processing plant, and they have 400,000 chickens there. And those chickens get slaughtered, and they produce a lot of blood. So we started bringing in tanker trucks of chicken blood, turkey lungs, beef blood, municipal and agricultural lubricants. So the plant loved it. The workers, not so much, but it took a while, and we got over that hurdle as well. So as you can see here, we begin to take in a number of waste. Some low strength, many high strength. The high strength go into the digesters. Digesters produce methane gas. So all of those waste I just mentioned, those are liquid waste, something that a treatment plant has a lot of experience in dealing with, pumping, bringing in the liquid waste through our treatment process. Then we expanded to something else, and this was in about the last 4 years, and that is solid waste material. So this is a picture of source-separated solid waste. This is very nice, good, solid, source-separated solid waste. This is from grocery stores and restaurants. All those food scraps that are left on the table in the restaurants in the Bay Area go into a bin. They get source-separated, and you can take that material and bring it to a treatment plant. Same with grocery stores. Produce gets chopped up, has to go somewhere. This is very good. This is what you actually get. The problem is, and we found out very quickly, is the concept of bringing in a solid material into a wastewater treatment plant presents significant challenges. So we worked with haulers, and we said, okay, if you can grind and screen the material to remove the coarse contaminants, and the contaminants we're talking about, these types of contaminants, chopsticks, bottle caps, glass, clamshells, a lot of clamshells, silverware, napkins, all of those things that you would hope would get source separated at the restaurant, but not exactly. So if the hauler can do that coarse screening, we said we would develop a fine screening to remove the rest of the contaminants. We did that, and we patented a process to do that. The other concept is we had, when we started this whole program, from the very get-go, we said, we're not going to have the model, the Kevin Costner model in Field of Dreams, build it, they will come. Our model is when they come, build it. So what we found was happening as the trucks went from 1 in 10 years to 10, 20, 30, 40, we're now over 120 trucks a day, that we needed to build facilities because our plant was not equipped to take in that many trucks. So one of the facilities we built was this, what we call our high-strength liquid waste, solid waste receiving station. So what we have here is, it's an aerial photograph, and trucks pull up here, they can connect up to these hoses and dump liquid waste, and these are hatches that open up, and these are underground tanks where it's mixed slurry with effluent from the treatment plant, and then pumped to the digesters, where it undergoes anaerobic digestion over a period of about 15 days, produces methane gas. The solids become stabilized, they turn into biosolids. They're used for application on non-food crop agricultural lands, and we get this wonderful methane gas from this waste material. Much of that waste material had previously gone to landfills. This is a truck, a 20-ton truck that is end dumping. This is what we get from the haulers. So this is a ground and a screen of food waste. So if you take one of these 20-ton trucks, that can power 200 homes for a day. So what we were finding is locally available feedstock that was sustainable. We were diverting waste from landfills. We were producing renewable energy because the renewable energy was from a waste material. It uses our existing infrastructure to the benefit of our ratepayers, and it supports a whole number of state, regional, local goals regarding landfill diversion, energy production, and greenhouse gas reductions. So we had some pretty good results. Here's way back in the early 2000s. We were producing about 900 standard cubic feet of biogas, and up here we're about 2,600, and that's increasing. The other thing is that we're generating tip fees. So as these trucks come into our gate, we developed a computerized system for monitoring those trucks, building those trucks, and we're generating, last several years, it's been around $9 million per year. And of course, we're diverting the waste from the landfills. So this is sort of the proof of the pudding in terms of how this can benefit a wastewater treatment plant. So over here we have annual revenues. So the blue represents the tip fees. So this is what we charge the trucks as they come in. The green represents the energy value that heretofore we've been using in our plant to actually power our plant. So as you can see, we started slow, and as it's been continually increasing here, this red line that goes up is along this axis, and this is accumulated tip fees and revenues. And so as you can see, after about 10 or 11 years, we're about $70 million. Total value to our ratepayers. This helps our board of directors keep the rates to our ratepayers as low as possible. So we've been doing renewable energy for quite some time. A lot of treatment plants, particularly larger ones, have been doing this. In 1985, we built 3 internal combustion engines. They had a output of a total of about a little over 6 megawatts. And we were running based on the gas that was being produced from the solids that came in with the wastewater in the pipes. We're meeting about 40% of our plant load. So many treatment plants do that. It's fairly typical. If you take the solids from the waste that you're bringing in through the pipes, anaerobically digest it, and use that to produce renewable energy via internal combustion engines or turbines, you can meet about 40% of your load. So under the concept, again, of when they come build it, we found that this is our power generation station where those 3 internal combustion engines are housed. And what you don't see on here is you see flares. We have 4 large flares, and we were producing so much gas from our digesters that those flares were going all the time. Not a good thing. Not a good thing from air district perspective, not a good thing from a huge waste of energy. So our board felt that it was time to actually build a turbine. So this year we put online a 4.5 megawatt gas turbine, and this is a depiction of the turbine here next to the power generation station. So this is the turbine. Right here is air pollution equipment. This turbine actually is quite modest. It's nothing more than a jet engine. It's housed in a compartment. So it's something that you would almost see hanging off the wing of a plane as you were flying. But that's the gas turbine that we put in. Generates 4.5 megawatts of electricity. So here's what we've been doing. So you go back to 2000, and you can see the on-site production. So our on-site production has been going up, and our imports, which is in the blue, on-site is green, imports in blue. So you can see the imports have been decreasing. Now in this area right here, we have a treatment plant that was built in the 1980s. You have to rehabilitate treatment plants. So we were doing things with our digesters, where we had some of our digesters out of service. We were all overhauling our engines. But that project is coming to a close. We're going to have our digesters rehabilitated. The engines have now been overhauled. The turbine is online. So what we are looking at here for fiscal year, or for calendar year 12, is exceeding 100% of our plant demand. So this is what it looks like. So we're generating about 6 megawatts. We're anticipating that this would increase. Our demand is 5. Net sales back to the grid is 1 megawatt. One of the things that we're looking at is right now we're susceptible to the treatment plant is open 24/7. Tomorrow, I don't know if we're going to have 120 trucks come in or 1. And so we're looking at long-term contracts where we actually contract with local haulers, particularly with food scraps, because there is such a huge quantity of food scraps in the Bay Area, to dedicate those food scraps to our treatment plant. So making the energy water nexus, we all know that of all the energy used in the state of California, a significant part of it goes for water and wastewater. So if you have on-site generation and you're doing it from a waste material, you can increase the reliability of your treatment plant. So with our on-site generation meeting actually 100% of our plant demand, we are less dependent upon the grid, PG&E, for meeting our electrical loads. It also relieves congestion on the grid. Then you can become an exporter of electricity, and you can export onto the grid, which reduces line loss if you can use that locally via the through agreements with your power producer. So we're doing that. And then also, we do recycle water at our treatment plant, and recycled water is a very valuable commodity, particularly when it comes to the needs at power plants and refineries. So a good example is that our board has, over the past several years, commissioned a couple treatment plants that provide very high purity water to the Chevron refinery on the order of about 7 or 8 million gallons per day. So that's kind of what we're doing from the wastewater side of East Bay MUD in terms of energy and the wastewater water nexus with energy. So any questions? Yes.
Do you see business opportunities for the private sector in this area so that this becomes not just an East Bay MUD or the isolated large facilities, but becomes essentially a region-wide or statewide?
Yeah, I think there's a lot of opportunities for public-private partnerships. So I think it was in 2005, our partnership with Foster Farms, we were bringing in the chicken blood and producing renewable energy. We won the governor's Public-Private Economic Development Award for that. Partnerships with waste haulers who don't have the ability to generate renewable energy through a very efficient anaerobic digestion process. And this is one thing that I think is really important is you can do a number of things with waste material. You can compost. Compost is actually a very good thing, and there's a good place for composting, but you have to put energy into composting. Anaerobic digestion, you get energy out. So I think there's a lot of, you think of all the waste streams in a society, and you have a very efficient process like anaerobic digestion, and you have capacity at a treatment plant. I think there's some real partnerships there that could be developed. Yes?
You mentioned that one of the processes you patented.
Yes.
Okay. Has East Bay MUD done a conscientious, deliberate effort to look at its IP that it's developed over the years, to look at other ways of leveraging that IP, much to the same that you've done in terms of bringing in money for your ratepayer, saving your ratepayer?
We have, but we are a public agency, and to the extent that we patent, one of the drivers for us patenting it is to actually prevent a private entity from patenting it and then collecting royalties. We patent it, and we generally, our tendency is to give that to the public sector. So, I mean, it's part and parcel of being a public agency. Yes?
When you look at the waste being generated in the Bay Area that could be treated this way and used to create energy sources, and the unused capacity in the Bay Area, what potential for growth do you think there is in doing this on a larger scale in the future?
I think every treatment plant probably has some degree of unused capacity. There was a paper presented at a big national conference here a couple of years ago, and I think it was a study out of UC Berkeley, and they estimated that across the state there's about 15% excess capacity in digesters at wastewater treatment plants. So even a small treatment plant, it generally might have 2 digesters, we have 12, could take in waste, a couple truckloads of fat, oil, and greases, that type of thing, and generate renewable energy. I will say one thing is that we're getting very creative in the waste that we're looking at, because as other treatment plants have seen some of the things that we do and we're sharing with them, they say, I can do that as well. So we used to take a lot of trucks from outside our service area with fat, oil, and greases. Those now are going to other treatment plants. So in some way, it's kind of a entrepreneurial business model, and you're competing to some extent. So we're looking at other waste streams that perhaps we could treat and other POT, public oil treatment works, could not. Yes?
Kind of along those lines, how important to your business model is the tipping fee seem to be a big percentage, but if more and more people do this and implement something like this, that resource is going to be something either you'll have to pay for, or the tipping fee will be less. So if you could talk about kind of the longer term implications of that.
Absolutely. So, I mean, that was something that, again, a public agency, but this resource recovery program, we've gotten into the mindset of kind of a business type of entrepreneurial type mindset. So when we realized that, I think it was about 3 years ago, we were taking 70,000 gallons per day of fat, oil, and grease into our treatment plant. Today it's 30. So as other treatment plants, and we're a public agency, what are you charging? 11 cents a gallon, we'll charge 9. Pretty soon it's a race to the bottom. So you're absolutely right. All of these things are things that we have to consider as we move forward. But again, there is a lot of waste out there. So we're looking at waste that other people have not considered heretofore. And it's something that is in our business model. I don't know how much time I have, Alex?
10 minutes.
Okay. In the back there.
Two questions. What's the capacity of your tertiary treatment now, and how much water you're selling? And do we see new industry?
I'm sorry, you said capacity of tertiary treatment?
What's the capacity of tertiary treatment now?
Okay, so our recycled water right now, we have a plant at our main wastewater treatment plant. Because we have a large service area, we also have partnerships with other wastewater treatment plants that provide the source water, and then we work with them, make sure it's tertiary treated and purvey it. But at our treatment plant right now, our what we call our East Bay Shore recycled water plant is 2.7 MGD capacity.
And how much you sell to industry? The
What?
2.7? The entire tertiary?
No, so what we're doing right now is the plant itself has 2.7. We're building the distribution lines that will go out and serve. In this area, it's primarily irrigation. Up north, we have an agreement with the West County Wastewater District where we use their source water, and that's what we bring to a tertiary treatment plant and provide that to Chevron, and that's about 7.5 million gallons per day.
What do you see the challenges or obstacles when selling water to the industry, to the tertiary treatment?
Challenges in terms of selling the water? Chevron likes the water because it's very reliable, and when we have droughts, there are impacts across all of our customers in terms of rationing. We recently put in a very advanced system where we can bring in water that serves to lessen the impact of droughts, less rationing, but even in severe droughts there'd be rationing. So industry kind of likes the reliability aspect of that.
Reliability in terms of quantity or quality of both?
Both. Yes, the quality that they require, we're providing very high purity water to their boilers. And this requires the highest purity you can get, and it goes through double pass reverse osmosis. We have we built a reverse osmosis plant, and they actually have a second reverse osmosis plant that makes sure the quality is appropriate.
That's a plant program that promises of shares, right?
Pardon?
Where the treatment that reverse osmosis sits?
Yes, it's actually a treatment plant that we built. It's actually located on the Chevron plant site, and we operate it. Yes, the woman?
I appreciate the presentation. I think what you've done is very, very visionary. I have a simple question. In looking at your revenue generation charts, is that net, or if it's not, if it is gross, then what did you offset with the capital improvement that you've had?
That's a very good point, and it's something that that internally we've discussed a lot, we've discussed with our board, and so the generation is not net. So, but what you would have to do is you would have to subtract out the actual cost of that. This project, this resource recovery project, has in gross terms, a significant benefit, financial benefit to our ratepayers. So if you take that $70 million total, we've spent in terms of actual capital, probably about $12 million in actual capital. And then you have staff time. We have a resource recovery program that's headed by a staff of about, I think it's 5 people that oversees that program. So they do things like go out to trade shows. We have a booth. We go to winery shows, say we can take in your waste. Because it's a constant, like a business, it's constantly, you're losing customers and you're gaining customers, so it's a process. But the one thing, and I think our board likes this concept, is that we want to be green. Everybody wants to be green, but we're not doing it just for the sake of being green. We're doing it because this has a financial advantage. Yes?
The regulatory environment, getting the permits, because sometimes innovation and visionary things don't go well with getting the permits, and it can be challenging. It's mission highly improbable. If you could share us some of that information.
Right, so I presented here a 15-minute overview. There's obviously a lot of work that has gone into. Our number one job here is to treat wastewater and make sure that we're meeting our permit limits. We have a record of meeting our permit limits for 158 consecutive months and have won national awards for that. We, very early on in this, did a full disclosure with the regional board saying this is what we're proposing to do. This is the processes that we have in place to ensure that we can meet our permit limits and protect the operation of our plant. And they think it's a very good idea, and it's actually mentioned in our permit. The other thing is that kind of the unintended consequences. So you start this program, and then suddenly we found that there's other agencies who feel like they would like to regulate us as well. So and it's something we're dealing with. So we have so the issue of chicken blood. So we have California Department of Food and Agriculture. The issue of bringing in fats, oil, and greases. We have Cal Recycle. And so it's like, hey, we're regulators too. We'd like to help you out. Yes?
So this is really visionary, from 10 years ago. And who is the champion for this vision? Is it coming from the board?
John Coleman. No, I was making a joke, obviously, but no, the point is that we have briefed our board many, many times on this, and our board has been very, very supportive of this concept, and we've had some national recognition from doing this. And probably the most gratifying thing is I think our board is out and about, and when they see other treatment plants actually copying what we're doing to their benefit as well. I think this could never have been done if you did not have a board that was supportive of the efforts that you were doing. In terms of individual ideas, it comes from a huge effort, a team effort on the staff, thinking about new ways of doing things, meeting the challenges of taking in a new waste stream, that type of thing. Yes?
If I may, I have 2 questions. One is, it sounded like you're exporting generation.
Yes.
So if you could speak to what your relationship is for those exports, and whether you have registered the renewable energy credits for the generation.
Right. So way back in the mid-1980s, when we first built the IC engines, we realized that there might be some period of time, middle of the night, whatever, when our energy demand was really low. So we had an agreement with Pacific Gas and Electric to just, as we generated a small amount of excess energy, we could sell it back to them for a nominal amount. I think it was 3 cents. Since we've been generating more, we have gone out with a request for proposal and looked for other folks who are interested in increasing their renewable energy portfolio. Our board just recently approved an agreement with the Port of Oakland that we're getting 7.2 cents, which includes 3.5 cents for the RECs. So when
So
we
you're selling them the bundled product?
bundle the product, we're selling them. And so that's quite a bit additional revenues from the old 3 cents with PG&E.
Are you registering the renewable energy credits associated with what you're consuming so that you can claim that from a?
No, if
For
we,
UB
if we're
32?
using it ourselves, it's,
You're not.
right.
Okay. Thank you.
That's my
Yes.
two questions. Number one, how you meet your peak power demand, which you said 10 to 11 megawatt, and you generate about 6.
Right, so we do have, during short periods of time, during significant wet weather events, we have a power demand that exceeds. So years ago, we entered into an agreement with the Western Area Power Association, and they provide what is called a custom product to us. And so that helps us shave the peaks off our power demand when we can't produce enough on site.
Second question is on this food waste which you get it. Are you feeling a problem of grinded glass going to digesters, and also some biosolid property problem?
Yeah, so the food waste is obviously our biggest challenge. I mentioned we patented a process. It was a process that we developed in-house, and but it's not the best process. So we're looking at other technologies that are actually being used in Europe right now. And one of the issues is when you're bringing in these, particularly the food waste material, you're getting huge amounts of grit. So we need to get that grit out because that ends up in the digester, increases the cleaning frequency. So one thing is, this has not been a bed of roses. There have been so many hurdles and challenges that you have to overcome, and it's an ongoing process to do that.
No, if you have it, one more, Tom.
I was just curious, does your power production, does that require to be licensed by the FERC, or is it exempt?
No, we're not licensed by
Federal
federal.
Energy.
No.